The ocean is Earth's greatest mystery. It covers most of our planet, yet we have explored so little of it. Imagine plunging into the deep, dark water, far below where sunlight can reach. Down here, the pressure is immense, the world is completely alien. Incredible creatures, breathtaking landscapes most will never see, but something else is hiding in this darkness, something powerful and ancient. A force that shapes our world from the bottom up, a force of incredible heat and creation. I'm talking about volcanoes, not the kind on land. They are deep beneath the waves, scattered across the ocean floor. These underwater giants are among the most active on Earth. So, what exactly is an underwater volcano? Well, it is pretty much what it sounds like. It is an opening or a vent in the ocean floor that allows hot molten rock from deep inside the Earth to escape. This molten rock is called magma. When this magma comes out of the volcano, we call it lava. These volcanoes are also known as submarine volcanoes. They can be found in every ocean on Earth, from the shallow waters near coastlines to the deepest, darkest parts of the abyss. They come in all shapes and sizes, from small cones that are only a few hundred feet high to massive mountains that would dwarf anything we have on land. Most of these underwater volcanoes are found along the edges of Earth's tectonic plates. You can think of these plates as giant, slow-moving puzzle pieces that make up our planet's surface. Where these plates are pulling apart, magma rises up to fill the gap, creating long chains of volcanoes. This is happening right now, along the mid-Atlantic ridge, which is like a giant seam running down the middle of the Atlantic Ocean. This is the longest mountain range on Earth, and it is almost entirely underwater and made of volcanoes. Other volcanoes are found where plates are crashing into each other, with one sliding beneath the other. The biggest difference is the immense pressure from all the water above them. The story of how an underwater volcano is born begins deep within the Earth. Our planet's core is incredibly hot. This heat creates currents in the mantle. Those currents make tectonic plates drift. Where plates pull apart, a gap opens. This is where the magic happens. Lower pressure lets mantle rock melt into magma. Magma is less dense, so it rises, like a hot air balloon. It finds cracks and fissures in the ocean floor. That's the birth of a submarine volcano. At first it's a small vent, lava oozes out and hardens in cold seawater. Each pulse of magma makes it grow. Layer upon layer of cooled lava builds up over thousands of years or even millions of years. It starts as a small mound, then becomes a cone, and can grow into a massive mountain on the seafloor. We call these seamounts. Underwater eruptions are incredible to witness. On land, volcanoes spew ash into the sky, but underwater eruptions are more contained by water pressure. When lava emerges, the outer surface is instantly quenched. It forms a glassy crust while the interior remains molten and hot. The molten interior pushes, cracks the crust and oozes more lava, which then hardens. Repeat this and you get pillow lava, those rounded, pillow-like flows. In shallower water, eruptions can be dramatic. Heat can flash boil seawater, creating explosions of steam, gas, and shattered rock. These are phreatomagmatic eruptions, powerful enough to send plumes of ash and steam above the ocean. They can create temporary pumice rafts. Pumice, volcanic rock so light it floats. Over time, a submarine volcano can break the surface and become an island like the Hawaiian Islands or Iceland. When an underwater volcano erupts, it is one of the most powerful and creative events on the planet, even if it happens in total darkness. The first thing that happens is the release of immense heat. The lava can be over 2,000 degrees Fahrenheit and it hits seawater that is just a few degrees above freezing. This extreme temperature difference causes some amazing things to happen. The water that comes into direct contact with the lava can be instantly vaporized, creating huge bubbles of superheated steam. Along with steam, the eruption releases a huge amount of volcanic gases that were trapped in the magma. Carbon dioxide, sulfur dioxide, hydrogen sulfide, the same gas that gives rotten eggs their terrible smell. In the deep ocean, the immense pressure can force these gases to dissolve directly into the water. In shallower eruptions, they can rise to the surface as massive bubble plumes. The eruption also spews out a cocktail of minerals and tiny rock fragments. This creates a dark cloudy plume in the water that scientists call a mega-plume. These plumes can be enormous, spreading out for miles from the eruption site. They are filled with tiny particles of volcanic glass, iron, manganese. These particles slowly drift through the water and eventually settle on the ocean floor, creating a distinct layer of sediment. It might sound strange to think that a violent volcanic eruption could be a source of life, but that is exactly what happens in the deep ocean. These volcanoes are the ultimate architects of the seafloor. Every time one erupts, it adds a new layer of rock, building the foundation of the underwater world. The long chains of volcanoes at mid-ocean ridges are constantly creating new oceanic crust, a process called seafloor spreading. This is literally how the floor of the Atlantic Ocean was formed, and it is still growing wider by a few inches every year. It is like a slow-motion construction project on a planetary scale. Over millions of years, these eruptions do not just create flat seafloor, they build incredible structures. They form massive mountain ranges, they carve steep canyons, they create countless individual seamounts that dot the ocean basin. These seamounts become critical habitats in the otherwise flat, muddy, abyssal plain. They act like underwater islands, creating complex surfaces where animals can attach. They provide crevices where animals can hide. They offer places for animals to live. The rough, craggy surfaces of the lava flows provide homes for sponges. Corals colonize those surfaces. Other filter-feeding animals also thrive there. It is a classic example of how geological forces directly shape the biological landscape of our planet. When a volcano becomes so large that it breaks through the ocean's surface, it forms a brand new island. The Hawaiian Islands are a perfect example of this process. They are essentially the tops of gigantic underwater volcanoes, built up from the seafloor over millions of years of eruptions. Once an island is formed, it becomes a blank slate for life. Birds arrive, carrying seeds from other lands. Plants take root in the new volcanic soil. Eventually, a complex ecosystem is born from what was once just molten rock. Even after an eruption stops and a volcano goes dormant, its influence continues. The seamounts it created cause deep ocean currents to change direction and swirl. These currents bring nutrients up from the deep. That upwelling creates areas of high productivity in the water column above the seamount, attracting plankton, small fish, larger fish, and sharks and other marine mammals like whales. These underwater mountains become bustling oases of life, hotspots of biodiversity in the open ocean. So, from the moment they erupt to long after they fall silent, underwater volcanoes are constantly building and supporting worlds, on the seafloor and in the water above. One of the most mind-blowing discoveries related to underwater volcanoes is the existence of hydrothermal vents. These are like hot springs on the ocean floor. They are almost always found near volcanically active areas. Here is how they work. Cold seawater seeps down into cracks in the ocean crust. It gets closer to the hot magma chamber and becomes superheated, sometimes to over 700 degrees Fahrenheit. That hot, mineral-rich water shoots back out through vents in the sea floor. A spectacular sight. Fire and ice meeting on the ocean floor. When superheated fluid hits near freezing water, minerals instantly solidify into towering chimney-like structures. These chimneys are called black smokers because the fluid is so rich in dark minerals, iron, sulfur, it looks like thick, black smoke. These chimneys can grow incredibly fast, several feet in a single week. They form an otherworldly landscape of jagged spires and delicate mineral formations, all shimmering under submarine lights. It's a chemical factory powered by volcanic heat. Before their discovery in 1977, scientists thought all life depended on sunlight and photosynthesis. But there is no sunlight this deep. The discovery of vibrant vent ecosystems changed biology forever. Here, life is powered by volcanic chemicals. Tiny microbes use hydrogen sulfide and other vent chemicals to create energy and chemosynthesis. Those microbes form the base of a whole new food web, and the life that builds on that base is incredible. Vents are crowded with bizarre, beautiful creatures found nowhere else. Giant tube worms, some over 6 feet long, with bright red plumes, and no mouth or stomach. They get energy from chemosynthetic bacteria living inside them. Ghost white crabs, strange vent fish, dense beds of mussels and clams. A true oasis, powered by the hidden fire of the underwater volcano. Our exploration of underwater volcanoes has led to some of the most incredible scientific discoveries of the past century. One of the most amazing things we found was a type of shrimp at a vent site in the Caribbean that has no eyes in the traditional sense. Instead, it has a special light-sensing organ on its back. Why would it need that in total darkness? It turns out that the super hot water of the vents gives off a faint invisible glow, a type of thermal radiation. These shrimp can see this glow, which helps them navigate the dangerous superheated environment without getting cooked. Another wild discovery came in 2006 when scientists witnessed an underwater volcano, the West Mata volcano near Fiji, erupting in real time at a depth of nearly 4,000 feet. Using a remotely operated vehicle, they captured stunning video of glowing lava bubbles and explosive bursts. They saw the formation of pillow lava, and a special type of lava called bonanite, extremely rare and forming at very high temperatures. It was the deepest ocean eruption ever witnessed, a first direct look at how much of Earth's crust is formed. Scientists also discovered the Lost City, a hydrothermal vent field in the mid-Atlantic that is completely different from black smokers. Instead of being powered directly by magma and producing black acidic fluid, these vents form by a chemical reaction between seawater and mantle rock, producing cooler, alkaline fluid and colossal white carbonate chimneys, some nearly 200 feet high. Perhaps the most profound discovery is the sheer diversity of life. Every time we visit a new volcanic seamount or vent field, we find new species. We have found furry-looking hawk crabs. We have found scaly-foot snails with iron sulfide scales like a suit of armor. We have found blind white eels that gather in writhing masses around warm water. These discoveries tell us life is incredibly resilient and adaptable, and they give us clues about what life might look like on other worlds, like Jupiter's moon Europa, which may have a liquid ocean beneath its icy shell, possibly heated by volcanic activity. Exploring the world of underwater volcanoes is a huge challenge. We cannot just hike up to one with a backpack and a rock hammer. These volcanoes are located thousands of feet deep in the ocean. Crushing pressure, total darkness, extreme temperatures. Getting there requires some of the most advanced technology on the planet. The journey usually begins on a large research ship. These ships are floating laboratories equipped with sophisticated sonar systems that can map the ocean floor in incredible detail, revealing seamounts and ridges never seen before. Once scientists identify a promising spot, they send down the real explorers, submarines. Some are human-occupied vehicles, like the famous Alvin, taking scientists to the seafloor for a first-hand look. However, these dives are expensive and risky. More and more, scientists rely on remotely operated vehicles, ROVs, with powerful lights, high-definition cameras, and robotic arms controlled with amazing precision. ROVs collect rock samples, grab biological specimens, and deploy instruments. Cameras stream live video to the ship, where teams cheer at every discovery. Scientists also use autonomous underwater vehicles, AUVs, untethered subs that survey large areas, using sonar and chemical sensors to map the seafloor and sniff out volcanic plumes. By combining ships, AUVs, ROVs, and sometimes HOVs, scientists are piecing together the puzzle of deep-sea volcanic worlds, venturing into the last true frontier on our planet. So, why do we spend so much time, money, and effort exploring these dark, dangerous places? The answer is that underwater volcanoes hold some of the most important secrets about our planet. They are fundamental to how Earth works. By studying them, we learn about the powerful forces of plate tectonics, the process that drives earthquakes, builds mountains, and shapes the continents. Mid-ocean ridges, where most of these volcanoes live, are the source of all new ocean crust, resurfacing about 70% of our planet. These volcanoes also impact ocean chemistry. Hot, mineral-rich fluids supply iron, manganese, and sulfur, essential nutrients, influencing ocean circulation and how much life the ocean can support. Microbes from these extremes yield enzymes for industry, medicine, and DNA analysis, a library of biological solutions, and we explore because it is in our nature. The deep ocean is our last great frontier. Every dive a real chance to see something no human has ever seen before. These volcanoes remind us our planet is dynamic, active, mysterious, full of wonders.